pad here, that's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3. 2. 1. 0. And liftoff of Sentinel-6 Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal.
Power and telemetry nominal. Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1, boost pack burn is started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an
Both
orange.
vehicles are following nominal trajectories. Fairing separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost pack burn shut down.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second
Both
stage.
vehicles continue to follow nominal trajectories.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. and then there will be a long coast phase today, and then we will have a very short, or a relatively short, second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Stage 1 entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It's incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Can you tell that we were excited? We were standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burn. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2. And we're going to call that out. Here it comes. There it is!
Wow. Oh my goodness.
Coming in at an angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness, I might cry right now.
It's just slowing down so perfectly.
Perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my we heard that.
Oh, that was
And Falcon has landed at LZ4, landing operator
beautiful.
Speed into 11.100 on recovery 2.
I'm a little
The
teary-eyed right now.
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that sonic boom is recognizable wherever
and
you are.
reverberating through the valley
Oh,
here.
I know.
I felt that.
Well, what'd you think, Jesse?
I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
So much for having me. This has been amazing. Thank you.
Absolutely. Thank you. All right, well, the coast phase is about 45 minutes away, and so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment, but we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. I'm going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
It's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to, so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6 really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have delivered their part on time. And in very significant terms. The launcher we have just seen, but also very important instruments like the microradiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there is much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Right.
Sorry, this is a little...
You're coming back to me, or?
Yeah, we are. What would you like to ask me, so I can gather my thoughts?
It's okay.
Nadia? What difference is Sentinel-6 making to revolutionizing oceanography? Okay.
Still have 10 minutes.
You've got time. We've got plenty of time. We'll be out after the video. You'll have like six minutes.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed. Give me a cue.
Count you down.
The altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the questions the international community has to come together to deal with these problems, because each one of those assets, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of JSON-class altimeters, and what we expect to see a new science coming out of Sentinel-6 that it would open up new frequencies that give us a fuller picture of what do we know about the oceans. And ocean altimetry by now, it's a mainstream tool of modern physical oceanography. So if you are a modern oceanographer, at one point of your life, you clearly looked with this data. Either you're studying tides or sea level, ocean circulation, or winds or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer timescales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
To precision, which is essential because the annual changes are just a few millimeters a year. It's really remarkable. But it can do a lot more. And recent work shows that the oceans are taking up much more carbon dioxide from the atmosphere through the ocean-atmosphere interface, where waves play an extremely important role. Now, the Sentinel-6 Michael Freilich radar altimeter provides us with excellent measurements of the significant wave height with a 300-meter footprint size along the satellite track. Really, this will help us to improve our understanding of carbon dioxide transfer into the ocean. But it's even more than that. Wave forecasting is part of the Copernicus Marine Services for serving maritime operations, which are essential for maritime safety. And these are managed through the European Maritime Safety Agency. So we'll have topography measurements and wave measurements to really provide something pretty superb.
Well, thank you, Craig.
If you wish, it is up to you.
And that was Craig Donlan, who's the project scientist from ESA, which is the European Space Agency. So thank you so much to them. And the climate science conversation continues. If you would like to tune in, just use the Sentinel-6 hashtag on the European Space Agency or ESA's social media platforms.
This satellite was renamed after American oceanographer Michael Freilich, who led NASA's Earth Science Division for more than a decade. Freilich passed away in August, but 5 months prior, NASA held a satellite renaming ceremony for him at the agency's headquarters in Washington, D.C. Freilich accepted the honor, but he credited his success to the contributions of thousands of scientists, engineers, managers, and diplomats on both sides of the Atlantic.
It's been a privilege to work with you, to learn from you, and to be able to call you friends. The entire world is expecting great things from Sentinel-6, and I know that you will deliver. Go Sentinel-6.
Certainly, he would have been thrilled to see this launch today. Joining us now is Daniel Freilich and Sarah Freilich, Michael's children, son and daughter. Thank you so much for being here.
Thank you
so much for having us.
You're very welcome. So, you just saw this launch. Your father's name is on the satellite. What were your thoughts as you were watching that?
It was gorgeous. Like, I haven't seen something that beautiful before.
It's amazing.
It's my first time seeing a launch from out here, and to just see that was incredible. Like, it means so much to see and feel it. Like, I'd heard him talk about feeling it, and feeling that as it goes is just incredible.
Amazing.
And we all talk about him in the space community as just being such an inspiration. I had the honor of hearing him speak once as well. And you guys know the man outside of the work. So tell us a little bit about him.
So our dad was passionate, and like whatever he chose to do, he wanted to like be a big part of it, and like was in all of the communities. And I like to tell people I didn't have heartthrobs on my wall. I had ESA and satellite images as the posters. And so that was just who my dad was. He shared it with us, and you know, like he was always there.
And I think another thing is, you know, he cared about things at all levels. So not only did he care about an individual mission, but he cared about how it affected the entire world. And he did that with everyone he worked with. You know, he talked about the people that he worked with. He talked about all of the science that happened. When we were going through his papers, actually, we found that he still had the science papers written about the impact on the world. So even as he moved on, like he just cared about every part of the process, the people, the science, and what it meant for humanity.
You guys were sharing a nice moment with me yesterday when you said that you know, you have talked to the people who worked with him. They talked about you guys, and then he talked to them about you. And so just sharing, you know, the mutual experiences, and said that he was just the real person, the real deal.
Yeah, and he would push everyone to be their best in order to make everything better.
And we don't want to forget about Rosie here. This would be his grandchild, right?
His first grandchild that he got to meet, so that was very special. Yeah.
Beautiful. She's rocking the Sentinel-6 shirt. Look at that.
You know, Sarah, you're a science teacher, right? So what part of this kind of carries through to what you do today?
So I think like we do a big unit on climate changing, because like for me, sea level rise and like what we can do as individuals is so important, and like what my father was saying. And so as much as I teach science, and I hope that each student can find something that excites them, whether or not it's like physics, biology, like rising sea levels. But I want to make sure that there's a space for everyone to find something that interests them.
And Michael Freilich had a red pen. Do you have a red pen?
Rosie has a red pen.
Rosie does.
Yeah, so Rosie got a
on the tradition, Rosie. Just mark it up.
And it's so important, like you said, for future generations to be inspired and make a difference. Thank you, guys.
That's what he wanted us to understand, that this was our planet and it needed to be better for everyone. And so he always said to us, it's not that there's climate change, but the climate is changing, to try to build unity around this topic and have everyone understand what impacts they can make and why it's important to all of us.
That's very well said. Daniel Freilich, Sarah Freilich, and Rosie.
Yes.
Rosie, we're so glad that you could be here for this moment.
Thank you
It's
so
just
much.
incredible, and thank you for sharing your father's legacy with us.
Thank you for having us.
Thank you so much for having us.
Michael Freilich believed strongly in the mission documenting sea level rise. Earth's oceans affect us all, from the air we breathe to how they impact our climate. Let's take a look at how Sentinel-6 Michael Freilich will help us continue to explore oceans from space.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. We're here at NASA's Jet Propulsion Laboratory, and we're really excited about this new satellite. It will extend the record of sea level rise another decade past the 30 years we already have, and allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet because sea level rise is one of the most important consequences of human-caused global warming. Sea levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space.
Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat.
Ocean currents affect our daily lives because the ocean has a strong impact on climate. In the west, the Pacific Ocean strongly determines droughts and rainfall, and in the east, hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe. We're excited about the technical capabilities of this new satellite and the prospect of another 10 years of sea level measurements.
That's a great call. I believe, Philip, help me. I believe that's a call for, like, we've completed the second stage burn, a nominal insertion orbit. That's where that's where we wanted to get to, right?
Exactly. Yes, the first stage did most of the work of getting out of that gravity well to get away from Earth into orbit, and then that second stage, second burn, was really just tweaking to get into that final circular orbit.
Yeah, fantastic. And we're seeing now some great shots from that second stage, and we saw the spacecraft there a second ago. So that track that the rocket has flown, it's tough to see because this image on screen is simulating being in the shadowy part of the Earth right now. So if you look really closely, you can see we're kind of approaching, if not in the Indian Ocean now, we're to the east of Africa. The track, as Philip mentioned earlier, that 66-degree inclination kind of put us around the tip of South America and then around the tip of Africa without actually dipping down to Antarctica. So kind of a fun track to take. We're expecting to have signal acquisition of the spacecraft. And why such a long coast phase? I know that for those that are familiar with rocketry, they kind of are accustomed to science missions and robotic explorers having a coast phase that can be fairly lengthy. But why this 45-minute coast before the second burn?
So with the rocket, we bring all the gas with us. There's not gas stations in the way. So we want to try and use as little as possible. And so just the way that it works is that, we start
Callie, I want to jump in there for a second.
We fly up in the early parts to a
We're looking at the spacecraft separation right now. I want to let you finish, but we're getting that live, and I wanted to call that out for you. So there goes Sentinel-6. That is a beautiful sight. Watching it drift off there. Again, we are kind of shaded by the Earth, so we're not in direct sunlight at this time. So that's why it's as dark as it is. If the sun were on this side of the Earth, we'd see a little bit more of that, but that's going to kind of just drift off, and that's completely normal and expected. So, Callie, I do want to let you finish. Sorry for jumping in there.
No, yeah, that's the exciting part when the rocket's done its job. So what we did was we got to a park orbit coast with the boost and the first burn. And so with that, we still had a perigee, so the point we're closest to the Earth, just above 160 miles. And so we're near that. And then we coast and just let physics do its job, where we go out to the furthest part, 800 miles. And then at that point, we just have to do a short burn, just over 10 seconds. A little bit more, and then we circulate the orbit. So we then are just using a little bit of fuel at that point. So
awesome.
Well, we thank you for joining us. That's our coverage of Sentinel-6 Michael Freilich, the launch of that satellite on a Falcon 9 rocket by SpaceX. We appreciate you being here. For everyone here at NASA, thank you for watching, and remember to keep looking up.